Today we're going to learn how to create the unit circle. And the unit circle is something that is extremely important for what we're going to be doing here in Algebra 2, as well as when you move on to pre-calc and calculus. You have got to know the unit circle really well. All right, so this is the first time we're seeing it, so I'm going to go through all of the steps of building the unit circle, and then you have this. I posted this on Google Classroom so that you can see this and you could be filling it out as you go as well. And if you notice at the top of it, it does say practice filling in this unit circle until you can complete it in 5 minutes. So there's not going to be any sort of test on it this year, but it is something that you need to know this. So the more you practice with this and the more you know this, the better off you're going to be. All right, so here we go. We're going to place the degree angle measure of each angle in the dashed blanks inside the circle. So we're going to start there. That should be pretty easy. So we know that here we're starting at 0 degrees, and then this would be 90. We know over here is 180, 270, and then 360 back here again. So we do want to make sure that you're putting the degree symbol with those as well. And then as we're going, each big jump is 30 degrees, and each little jump is 15 degrees. All right, so we're going to go through and fill in the rest of those angle measures. Again, every big jump is 30 degrees, and every small jump is 15. Okay, so there is degrees. Now, the next thing to do is to fill out radians. Now, we've learned in the past how to convert radians, degrees to radians. We also know that this should be 0 pi, this is pi over 2, pi, 3 pi over 2, and then 2 pi. So we do know those things as well. And you could go through the steps of converting 30 degrees into radians by taking 30 and multiplying it by pi over 180, and noticing that 30 goes into 180 6 times, so that's going to make this be pi over 6. And you could do the same thing with each of these other ones as you go. But we obviously, if we're trying to get this done in 5 minutes, don't want to take a ton of time doing that. So what we're going to do is kind of look at pieces of pizza, kind of as I've been talking about in the past. So if we look at this 30-degree piece of pizza, that's 1/6, because there are 6 pieces of pizza that are that same size by the time we get over here to pi. So I would have 1/6. 2/6 would be over here at 60 degrees, and 2/6 is going to simplify to be 1/3. And then 3/6, which is 1/2. 4/6 simplifies to be 2/3. We have 5/6, which doesn't simplify, and then 6/6. And we're going to keep going, counting our sixths and simplifying them as we go, including, you know, our 90-degree angles as well. So we would have 5 pi over 3 here, and then this would be 11 pi over 6. Again, so we've skipped over the 45-degree angles at the current moment, and that's okay, because those weren't 30-degree pieces of pizza going around. So we should have 12/6, which simplifies to be 2 pi, so we're good to go there. All right, next thing then is looking at those 45-degree pieces of pizza. So here, if we take a big and a little chunk together and get 45 degrees, how many of those pieces could we make in the top half of this? We could make 4. So one of those then would be 1/4. 45 degrees, it goes into 184 times. That's where you get the pi over 4 from. So that would be 1/4, 2/4, which is a half. Then we would have 3/4, 4/4, which is just pi. 5/4, 6/4 is 3/2, 7/4, and then 8/4 is our 2 pi again. Okay, so that is the degrees and radians all around the circle. Then the next thing is to place the coordinates of each of these. Okay, so we're on an XY coordinate plane here, and it is called a unit circle because the radius is 1 unit long. It doesn't matter if that unit is a centimeter or a millimeter up to a mile, whatever it is 1 meter long. So if we're here, this is our origin, and we're over here at 0 degrees, we would have gone +1 in the x direction and 0 in the y direction. So the coordinates of this point here are 1, 0. If we're up here at 90 degrees, whoops, we have gone 0 in the x direction and a +1 in the y direction. Over here at 180 degrees, we've gone left 1, so that would be -1, and then we didn't go anything in the y direction. And then here we would be at 0 and then -1, okay? And then back over here, whoop, I did not mean to make that mark there, but 1, 0 again for 360 degrees, because we know that 0 and 360 are coterminal with each other. All right, so let's look at how the heck we're going to figure out what the rest of these are. So we're going to look at our 30-degree angle next here. And in order to do that, I'm actually going to draw in a bigger triangle for us to focus on. Okay, so we know that that's 30 degrees. We're dropping down a perpendicular to make a 30, 60, 90 triangle, which we've also seen in the past. So we have to remember what our rule is for 30, 60, 90. So the side across from the 30-degree angle is x. The hypotenuse is 2 times x, and then the longer leg, or the leg across from the 60-degree angle, is x radical 3. So if we're in a unit circle, that means that this distance here is 1, because if we're looking back at our circle, if we were to create that triangle, the radius is our hypotenuse here. Okay, so our hypotenuse is 1. Well, if we're at the 2x side, and that's 1, and we're going backwards to x, we need to divide that by 2 to get a half. Okay, and then to go from the short leg to the long leg in a 30, 60, 90 triangle, we're going to take that short leg of x and multiply it by radical 3. Well, when you take this and multiply it by radical 3, you're going to get radical 3 over 2. Okay, that means if we're looking at the coordinates of this point, because that's that point for 30 degrees, if we're looking here, our coordinates, we've gone from the origin here, we went radical 3 over 2 spaces in the x direction and 1/2 spaces in the y direction, because we went up a half. So I'm going to go back to my unit circle here. And that means here we have radical 3 over 2 and then 1/2. Okay? Now let's look at our 45-degree angle. So again, we're going to drop down a perpendicular, and I'm going to use different colors for each of these. Okay? So again, we're drawing in a triangle. Oh, it doesn't really look like isosceles there, but it is. Okay, so this is an isosceles triangle. Again, the hypotenuse is going to be 1. In any 45, 45, 90 triangle, our legs are x, and the hypotenuse is x radical 2. So if we are at the hypotenuse, and that is 1, so we have to look at this formula, x radical 2 equals 1, and we have to solve that to get x. So we're going to divide by radical 2 on both sides. But we know that we can't leave it like that, so we need to rationalize by multiplying by radical 2 over radical 2. So that means that we would get radical 2 over radical 2. So we would get radical 2 over 2. And that is what both of these sides are then, since those are both x. So if we're looking at the coordinates of that point right there, we went radical 2 over 2 in the x direction and radical 2 over 2 in the y direction. So those are the coordinates on our unit circle. So I'm going to go back here again, and we will fill in radical 2 over 2, radical 2 over 2. All right, that moves us right along to our 60-degree angle. So again, we're going to drop down a perpendicular, and when we do that, again, we're going to have that hypotenuse being 1. So now we have this triangle. Here is our 60-degree angle now. There's 30, it's a right triangle. We know that our hypotenuse is 1 for this triangle. All right, so 30, 60, 90, short leg is x, hypotenuse is 2x, long leg is x, radical 3. Well, where did we see this before? We saw this up here when we did our 30, 60, 90 triangle. The only thing that's changing here is that instead of this base angle down here being 30 degrees, it's now being flipped so that the 60-degree angle is now down at the bottom. So that means that the same things would happen in terms of your side lengths. So to go from the hypotenuse to the short leg, we're going to divide that by 2. To go from 2x to x, we're going to divide by 2. And then to go from the short leg to the long leg, we're going to multiply that 1/2 by radical 3. So it's going to give us radical 3 over 2. So if we look at the coordinates of this point, then we went 1/2 in the x direction and radical 3 over 2 in the y direction. So we're going to go back and fill those into our unit circle here. So we went 1/2 and radical 3 over 2. Okay, so we already know 90 degrees. We've got that going on there. So the next angle would be 120 degrees. Okay, so if we look at 120 degrees, now we're coming from the origin, the center of that circle, this direction with our triangle. This base angle is 60, this is 30, and that's a 90-degree angle. So we have that same exact formula that we had over here. Now, what do you notice? And this purple mark shouldn't be there. So this hypotenuse is still 1. To get to the short leg, we're going to multiply, or we're going to divide it by 2, and to go from the short leg to the long leg, we're going to multiply by radical 3. Now, keep in mind, though, we said before that this was like a coordinate plane. So if we're going this way, what do we know about this 1/2? It's got to be negative. So the coordinates of this point are negative 1/2 radical 3 over 2. So we're going to fill that back into our circle here. So negative 1/2 positive radical 3 over 2. We went left, but then we still went up. Okay? So using this information, I want you to work on filling out the remainder of the circle. Maybe you've picked up on the fact that we had 60 degrees. Those coordinates were the exact same as the 120, just that the x coordinate was negative. I want you to keep that in mind as you're looking at this. It is an xy coordinate plane. This is your origin, so this is 0, 0. So remember, if you're going left or down, those particular coordinates should be negative. Okay, and that's it.